Imagine a world where galaxies no longer exist and stars stop twinkling. What wonders lie beyond this newly revealed frontier? Is this just the beginning of a whole new chapter in our space travels? Or are we on the verge of solving the greatest mystery of all time? The James Webb Space Telescope appears to have reached the edge of the universe. You read that right. The final frontier may not be as infinite as you think. But wait a minute. How can there be a limit to space? It should have lasted forever, right? Let's see what's actually happening. When I first heard about this, I was thrilled that I had solved one of the many mysteries of the universe. This is what the James Webb Space Telescope is doing, and it's completely changing our understanding of the universe. This miracle, after just 12 hours of observation, has shown us things that make us scratch our heads and open our eyes wide. Imagine the true size of space. Think about how far your imagination can take you to the edge of the universe. Now let's determine the exact amount of space that the James Webb Space Telescope can actually observe. Don't waste any more time. Take a ride on a supersonic spacecraft that doesn't exist. The reality is incredible. We fly past planets like Mars, Jupiter, Saturn, Uranus, and Neptune, and we fly to the edge of the solar system. We have now passed 100 astronomical units and reached the heliosphere barrier. Voyager 1 and 2 passed this point and entered interstellar space. As we approach the Oort cloud, which is about 200,000 astronomical units from Earth, we simply pass through an asteroid and eventually fall into complete darkness. In a matter of minutes, we fly past planets and stars to the edge of the galaxy. At this point, we can only see the bright spots of our neighboring galaxies, and there is no longer a curved boundary. As we go along, we discover that other universes may exist, and that the limit of our galaxy is 10 billion light-years. A collision with another universe could create the first supergiant voids that are 1 billion light-years across. But how do we get to those other universes? Perhaps the answer lies in black holes, which distort time and reality beyond explanation. Some scientists even suggest the existence of white holes, the opposite of black holes. They are believed to potentially lead to other universes. Remember the Big Bang in 2006? This inexplicable burst of energy may have been a young white hole that was destroyed almost immediately. Now let's talk about the Andromeda Galaxy, which is moving at 68 kilometers per second. Don't be alarmed, because it won't come to us tomorrow. But it will be interesting when it does. Maybe our solar system will be launched into the dark of space like a tennis ball released from a string, or maybe we will see a celestial collision in the future. When the black holes at the center of the merging galaxies start dancing, they will eventually merge to form a supermassive black hole. This process releases energy, creating an active galactic center that can be seen from millions of light-years away. Next we come to the South Pole Wall, which is 500 million light-years away and contains 1 trillion stars. The Great Wall of Hercules Corona Borealis is a massive structure spanning 10 billion light-years. And don't forget the massive quasar group, which is 6.1 million times more massive than our Sun and spans 4 billion light-years. Then there's the observable universe, which is made up of over 500 billion galaxies, each containing billions of stars. But wait, there's a void that's 1 billion light-years wide, known as the Boat's Void or the Great Void. Some believe this is because the two bubbles come into contact and the universes are torn apart when they collide. Think of the universe as a giant bubble with potentially endless bubbles, which could be connected by wormholes or gates inside the black hole. The idea is to fold the paper so that 2 points are connected without covering the entire page. If the gravitational influence of the black hole increases over time and prevents spaghettification, it might be possible to survive the fall into one and go to another universe where the physics are different. But now it's just a ridiculous theory. Imagine looking at the stars on a clear night. They may seem evenly distributed, but they're not. All of these stars form a vast cosmic web that connects worlds across the universe. Recently, astronomers using the James Webb Space Telescope stumbled upon what is probably the earliest thread of this vast network ever discovered. According to 2 papers published in the Astrophysical Journal Letters, researchers using data from the James Webb Space Telescope have discovered a surprising discovery: a titanic ring of 10 closely spaced worlds spanning 3 million light-years. The team was astonished by the structure's length and density. It exceeded their expectations. University of Arizona astronomer and research team member Shani Danieli likens the discovery to finding ancient treasures hidden in a vast vault. These ancient gases and stars were formed just 830 million years after the Big Bang, when the universe was forming. And guess what holds these ancient threads in place? A really big black hole. But it's not just any black hole. It's a very bright celestial anchor. The TR project team responsible for this discovery calls it a spectroscopic study of the one-way corona during the reionization phase. Their goal is to figure out how the first black holes influenced the evolution of galaxies. They stumbled upon this ancient filament while targeting one of the 5 quasars of the early universe. Astronomer Fei Wang of the University of Arizona was delighted to find out, saying it was one of the first filament structures associated with a distant quasar. It was like finding a precious treasure map that contained the secrets of the early history of the universe. Now scientists believe that black holes are the primary factor in creating these massive webs, acting like magnets that pull matter together with their gravity. Interestingly, black holes can also use cosmic winds to push objects away. Even as galactic winds try to pull stars and dust across the universe, gravity acts as the glue that holds them together. Eventually, these ancient filaments will likely come together to form a group of galaxies similar to the Coma Cluster, which is about 33 million light-years away from Earth. It's like watching the universe expand over the years and create its own masterpiece. When the Webb telescope focused its mirror on a part of the sky, it observed far more light and galaxies than expected, not just galaxies but large, bright galaxies. Researchers are now speculating and formulating various theories to explain this cosmic mystery. Option 1. In the early universe, stars and galaxies may have evolved more efficiently and differently. Stars and galaxies are more likely to form quickly in a dark environment with few other people around. This deviation is unexpected, but not entirely surprising. Option 2. What if the source of the brightness is not a star but a massive black hole? Then we might be looking at a galaxy illuminated by this mysterious black hole, rather than a universe full of stars. But this contradicts our current understanding of how many black holes existed in the early universe. Option 3. The most radical scenario is that we don't fully understand cosmology. That would be like discovering that a key ingredient is missing from the recipe book of the universe. Option 4. Special case, we may not have considered all the unknown aspects of the universe. It is important to understand where we are in the universe and how we got here. If we miss something important in the story, it is like trying to solve a puzzle without all the pieces. As we continue to explore, more questions arise. Recent discoveries made by the James Webb Space Telescope remind us of the vastness of the universe. We could have gone off course. A recent study made headlines when scientists claimed that telescopes had seen objects just 120 million years after the Big Bang, challenging the traditional cosmological paradigm. Whether or not the Big Bang happened, Einstein's theory that the universe was extremely old may not be true. The universe may not be as old as we think. Our intuition has fooled us, and we are beginning to realize that we don't fully understand the situation. The James Webb Telescope can see about 46.5 billion light-years into the depths of space. This is what we call the Hubble circle or Hubble range. And guess what? The most distant galaxy ever discovered by the telescope, MAX 0647 JD, is still within this circle, formed about 450 million years after the Big Bang. Our universe is now like an ever-increasing balloon, expanding much faster than the light beyond the Hubble circle. But that circle won't expand forever. The observable universe has a huge horizontal limit of 93 billion light-years across, like a giant shell. We can't see any more. How big is the universe beyond our giant shell? We're not sure. Some theories suggest that it could be 10 billion times larger than what humans can see, making it infinite. However, the uniform distribution of the cosmic microwave background radiation and the dispersion of matter suggest that our universe could be infinite. In essence, when we look into the universe, we are stepping back in time. The galaxies near Hubble appear more like cosmic fossils, remnants of billions of years ago, than images of the present. It's like stepping into a time machine, but instead of moving forward, we're looking back. The traditional cosmological model says that the entire observable universe collapsed into a singularity about 13.8 billion years ago. If the universe is finite, this is the generally accepted version. But if it is infinite, the Big Bang happened everywhere, even beyond what we can see. The galaxies originally were like dim, yellowish gems in the night sky, but eventually they took on more complex and colorful shapes, like pearls on a necklace. Today, there are more bright white galaxies. Over time, the night sky was filled with stars. If spacetime were spherical, then one day, after billions of years of expansion, our universe would stop expanding and collapse again. But if it were hyperbolic, space could continue to expand indefinitely, and all matter would eventually disappear. Even as our explorations come to an end, the question remains: are we merely scratching the surface of an infinite journey, or are we reaching milestones that no one has ever reached before? The answer may be light years away, but one thing is certain: the universe is stranger and more wonderful than we ever imagined.